You've heard of anti-aging hacks, cold plunges, fasting, maybe even some questionable supplements. But what if there was a pill, a single drug that could slow down aging, extend your lifespan, and even protect you from some of the worst diseases of old age? A drug with the potential to be a real-life fountain of youth. It sounds like science fiction, a snake oil salesman's dream, but this molecule is very real. It's called rapamycin, and it's either the greatest breakthrough in longevity science or the most overhyped promise since detox teas. We're gonna break down the hype, the hope, and the hard science behind this controversial molecule. Rapamycin isn't a new drug. It was discovered in the soil of Easter Island in the 1970s and has been used for decades as a powerful immunosuppressant to prevent organ rejection after a transplant. But a few decades ago, scientists made a startling discovery. In a petri dish, it seemed to significantly extend the lifespan of yeast, worms, and flies. Since then, the research has exploded, with rapamycin showing incredible promise in mice, extending their lives by as much as 25%. Now, people are getting a hold of it, and a new anti-aging trend has emerged. They call themselves biohackers, and they're experimenting with this powerful drug, hoping to be among the first to unlock the secrets of living longer. But is it safe? Does it actually work in humans for anti-aging? And what are the risks of using a powerful prescription drug for a purpose it was never intended for? Let's find out what we know, and more importantly, what we don't. The master switch. What is mTOR? To understand rapamycin, you have to understand the cellular pathway it targets. Think of your cells like tiny factories. They have a central command center that decides when to build, when to repair, and when to clean up. This command center is largely governed by a protein complex called mTOR, which stands for mammalian target of rapamycin. I know, a bit of a mouthful, but stick with me. mTOR is a master switch for cell growth and metabolism. When you eat, especially protein and carbs, your insulin levels rise, and your body signals to mTOR that it's time to grow. It tells your cells to build new proteins, to store fat, and to multiply. This process is essential for life, for growing from a baby into an adult, for healing wounds, and for building muscle. It's the go signal, but here's the problem. This go signal is also implicated in aging. Think of it like a car engine running in high gear all the time. It gets hot, it wears down faster, and it produces a lot of exhaust. In a similar way, constantly activated mTOR can lead to chronic inflammation, DNA damage, and the accumulation of cellular waste, all hallmarks of aging. In other words, a little too much growth signal for a little too long is a fast track to getting old. This is why things like intermittent fasting and calorie restriction are so popular in the longevity community. When you fast, you turn down the mTOR signal, giving your cells a break from constant growth. It's like putting your car in neutral for a while to let the engine cool down. But rapamycin does something different. Instead of just turning the volume down, it essentially mutes the signal entirely. It directly inhibits mTOR, the longevity connection from yeast to mice. The story of rapamycin's longevity potential started small. Really small. Scientists first noticed its life-extending effects in single-celled organisms like yeast, and then in tiny, unassuming worms and flies. The results were dramatic. These simple organisms lived significantly longer when exposed to rapamycin. This wasn't just a fluke, it was a consistent finding. But the real bombshell came when researchers started testing it on mammals. In a groundbreaking study, the National Institute on Aging, NIA, tested rapamycin on genetically diverse mice. The results were astounding. Both male and female mice showed a significant increase in lifespan, with some living as much as 25% longer than their untreated counterparts. Even more remarkable, the mice that started receiving the drug late in life when they were already old still lived longer. This suggested that rapamycin wasn't just preventing age-related decline, it was actively slowing down the aging process, even reversing some of its effects. The mice on rapamycin didn't just live longer, they lived better. They were more active, had better cognitive function, and showed a delay in the onset of age-related diseases like cancer and heart disease. The drug also seemed to improve their immune function, which is often compromised with age. This was the first time a drug had shown such a powerful and broad anti-aging effect in a mammal, and the scientific community took notice. The skepticism, of course, was high. What works in a mouse doesn't always work in a human. Mice and humans have vastly different lifespans and metabolisms, but the fundamental cellular pathways, like mTOR are conserved across species. This is why many scientists believe that what worked for the mice just might work for us. The question isn't if it works, but how well it works and at what cost. The human experiment, anecdotes in clinical trials. So, with all this incredible data in mice, what's happening in humans? Well, things get complicated. Remember, rapamycin is a powerful immunosuppressant. For organ transplant patients, the risk of infection and other side effects is a serious trade-off for not having their body reject a new organ. We're talking mouth sores, high blood sugar, increased cholesterol, and an elevated risk of infection. These aren't exactly ideal anti-aging side effects. This has created two separate tracks for human use. The first is formal clinical trials. Scientists are cautiously and carefully exploring whether rapamycin can be used to treat age-related diseases. For example, there are studies looking at its potential to treat Alzheimer's disease, Parkinson's, and certain types of cancer. These are targeted, monitored trials, and they are essential for understanding the drug's safety and efficacy in humans. The second track is the Wild West of biohacking, with promising mouse data and a belief that low intermittent doses won't have the same side effects as high daily doses. A growing number of people are getting rapamycin off-label. They're finding doctors willing to prescribe it for anti-aging and creating their own protocols. These are not medically supervised studies. These people are literally a self-appointed, non-peer-reviewed human trial. They'll tell you about improved energy, a stronger immune system, and better skin. They'll tell you their blood markers have improved and they feel younger. But as a healthy skeptic, we have to ask, is this real or is it a classic case of placebo effect and confirmation bias? When you are spending thousands of dollars on a risky drug and committing to an intensive regimen, you are highly motivated to believe it's working. And while anecdotes can be interesting, they are not data. We don't have large-scale, placebo-controlled human studies on rapamycin for anti-aging. We don't know if those low weekly doses are truly safe over a decade or two, and we certainly don't know if it's actually extending their lifespan. That's a very long and expensive experiment with no guaranteed outcome. The risks and unanswered questions. The healthy skeptic's checklist. The risk-benefit analysis for a young, healthy person taking rapamycin for anti-aging is entirely different from a transplant patient, but the risks are still there. Immunosuppression. Even at low doses, rapamycin has an immunosuppressant effect. This is its primary function after all. A compromised immune system makes you more vulnerable to infections, which can be particularly dangerous as you age. Is a few extra years of potential lifespan worth the risk of a fatal infection? Metabolic side effects. In clinical use, rapamycin can lead to insulin resistance and a higher risk of developing type 2 diabetes. It can also increase cholesterol and triglyceride levels. These are some of the very health issues we are trying to avoid with anti-aging strategies. Taking a drug that might extend your life but also puts you at a higher risk of a heart attack seems counterintuitive. Long-term unknowns. The longest clinical trials for rapamycin as an anti-aging drug in humans are still in their early stages. We have no idea what a 20-year regimen of this drug looks like for a healthy person. Does it increase the risk of rare cancers? Does it affect bone density? What happens if you stop taking it? The list of unanswered questions is longer than the list of known benefits. This is the central dilemma of modern biohacking. The allure of a shortcut is powerful, but a truly skeptical and scientific approach requires patience and caution. The longevity field is a gold rush, and there are many people selling expensive shovels. Just because a drug works in a mouse and has a sexy mechanism of action, that doesn't mean it's ready for prime time. So what's the verdict on rapamycin? Is it the secret to eternal youth, or just another overhyped trend? The truth is, it's a bit of both. Rapamycin is a fascinating and powerful molecule that has opened up a new frontier in the science of aging. The evidence from animal models is incredibly compelling, and it points to a future where we may be able to use drugs to slow down the aging process. But that future is not yet here. Right now, rapamycin is an unproven, potentially dangerous anti-aging strategy for healthy individuals. The risks are known, the benefits are anecdotal, and the long-term consequences are a complete mystery. For now, the most effective and safest anti-aging hacks are still the boring ones: a healthy diet, regular exercise, plenty of sleep, and avoiding stress. Rapamycin is a drug to watch, but not a drug to take. It's a tantalizing glimpse into a potential future, but a future that requires a lot more research before it's safe to enter. So next time a biohacker tells you they're popping pills from a petri dish, maybe ask them if they have a long-term care plan. If you enjoyed this deep dive into the truth behind longevity fads, hit that subscribe button. We're here to separate the science from the pseudoscience and make sure you're getting your health information from a credible source, not a Reddit forum. And if you're a biohacker who just got a prescription for rapamycin, maybe share this video with a friend. We're all in this together, trying to live a little longer and a little smarter. This video is for educational and informational purposes only. It is not medical advice and should not be used to diagnose, treat, cure, or prevent any disease. Always consult with a qualified healthcare professional before starting, stopping, or changing any medication, supplement, or lifestyle program. The views expressed here are neutral, science-based summaries meant to encourage curiosity and informed discussion.